Okay, let's get started. It's not in there. Question? Question?
Did you leave like the increment statement, the initialization statement, and the condition and the for loop and just have an infinite loop?
One more time?
Did you leave the condition inside a for loop empty and then just have like an infinite loop?
You leave what empty?
Just like leave it like that.
What do I put in here?
Nothing.
What do I put in here?
Nothing.
Are you asking me what that'll do?
Would it?
In this class, it'll get you a 0. When this executes, right, well, what will it do? It'll be an infinite loop. In this class, and any code review I've ever seen, it'll get you a 0, and or your code review will fail. Question? Question?
In the switch statement, do you write the condition in the parameter, or do you write the?
In the switch statement, this isn't a parameter. You mean right here?
Yeah, in the parameter.
That's an expression. But whatever. I understand why. You know, everything inside parentheses is not a parameter. It's like an if statement. That's not a parameter. But anyway, what is this? This is an expression. So in here you will have case value 1, case value 2. In other words, you won't really have value 1, value 2. You'll have a constant here, like 1 or 2 or an enumeration expression. So this will evaluate to an integer, whatever this expression is in here. And that has to match one of these values. And if it doesn't, if you have a default, it will go to the default. Questions?
For a while loop, if you also get the while loop empty, that's also an infinite loop?
I don't know. I'll have to look that up. But once again, in this class you would get a 0 for that thing you did with a while loop that was empty. Because, I mean, no matter what, we're also not passing code review. Because if you do pass the code review, then there's no purpose in having that code review. But that's a good question. I've never thought about that question because it never occurred to me to ever do that. But like it never occurred to me to ever do an empty for, right? Because believe it or not, I'm actually a good programmer. Question? Question? You guys know who's next? Question?
Would be a lecture following the exam right now.
Yes, always.
So the lecture going to cover anything we previously went over.
Will it, say again, will it cover what?
Sorry, I missed it.
It'll cover new topics.
Yeah.
Specifically, we're going to talk about methods.
Yeah, that's why I was confused.
There's more.
I thought we went over some methods 2 weeks ago.
2 weeks ago, and last week, and more this week. And there's always lecture after the exam, except for the final exam. Question?
Do you still want us to use P for naming like pointers?
I don't care.
Okay.
In other words, that's a convention that many people find useful, but I care about a meaningful name, right? And in these simple programs, meaningful names aren't terribly important because they're very simple and it's obvious. It's obvious to me the greater, right? But it's a good habit to get into. Is that it? Oh, question? 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 Back row.
You know it's going to be on the exam.
You bet. In some way, shape, or form. Did I cover? Well, let me ask you this. Did I cover them?
Well, you also covered
Everything I have covered, except for methods, is on the exam. That's the short answer. So you can think on that. Next question. Question? 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 Side row. Question? Question? Question?
Are there gonna be any trivia type questions on the exam?
Always. That's going to be my answer to any question about the format of the exam. Is always yes, be afraid. That's always my answer. So don't ever ask me questions about the format of the exam. Next, question. 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 Side row, that side. Question. 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 Time is it? Okay, we have time for at least another round. Question, question. You said come back to you.
I read up on everyone.
Yeah, outstanding. Good. Might want to do it before you get here next time. Question, 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 question.
The syntax of mallet, do we need to put in pointer before the, or in front of the mallet?
You mean a call to mallet? What is it?
Yeah.
What would be the point of not assigning the result to mallet to something?
You know, I don't know, maybe this is wrong. I saw int pointer p int.
You mean like this?
Yeah, and then after the equal sign, they would put parentheses int pointer in front of the mallet.
I mean, they would do this. We haven't talked about casting yet.
Oh, that's different.
But yes, the result of mallet is the memory address of the memory you just allocated, right? And you can't use the memory if you don't use the memory address, and to use the memory address, you have to stick it somewhere, right? Second row. We'll get there. Second row. Go down the second row, shake your head, or ask your question.
Oh, no.
You know you're about to have an exam, right? Just making sure. Next. 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 Third row. Trying to get that in. You guys are smart enough to figure out when it's your turn to ask a question or not. Question. Moving on down. Question. 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 Hang on, I'm gonna get to the fourth row in a second. Question?
So, in a lot of your examples, when you're making a pointer, you use the asterisk p. Is the p necessary, or is it just the asterisk that's necessary?
The asterisk is necessary. The asterisk is what denotes a pointer variable.
Right,
This
so
is
the
not
P
an
is-
integer variable, it's an integer pointer
Yeah.
variable.
Okay.
P, like she asked, is a common convention.
Okay.
So anybody, because if it's followed consistently, anybody sees P name, right? They will know it's a pointer to a name.
Right. Okay.
But it's not required. I have to pick some name to use as examples. Question. Question. Fourth row. Question. 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 Fourth from the fourth row. Question.
Me?
Yep.
Oh yeah, so I know that it doesn't matter because white space is ignored outside of strings, but by convention, where do you usually put the asterisk in between the int and the pointer name? Do you put it without a space next to the int or without a space next to the pointer name? Or do you put a space in between both?
You always put a space, right? Typically, you put it next to the variable name.
Okay.
And there's a reason for that I went over last week, because unfortunately in C, when you declare enums, we had an example, right? Let me use a quick example. So like, have an enum called weekend, and I put in it that sun, right? I can also then say weekend. I can also say and this is why. Because the fact that it, so this declares a variable called weekend, right? That is just an enumeration. This declares a pointer variable, a weekend pointer called weekday. That's why. But it'll compile either way. Whether you put the int next to the, the star next to the variable type, or whether you put the star next to the name, compiles either way. Next question. Hello? Somebody make a question.
Yes, if you have a chunk of code in the exam, like the last exam, it was not supposed to take into exacting each line, it just look at like each line as part of the whole, or is it going to be like each line considered by itself?
I don't understand the question. So
So-
if you have a question on the exam, come ask.
Okay.
In other words, walk up here and come ask me quietly. Because sometimes in asking the question, you give away answers, that's why you have to ask questions. Question, question, question. Back row. Question or no? No. Side row, my right side row. Question, 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 question. Other side row. Question?
For dynamic array and the array, what's the
The difference between what?
array and dynamic?
A dynamic array space is allocated at execution. The amount of space is allocated at execution. For a static array, if you say like int x bracket 20, that size of that array is known at compile time. But for a dynamic array, whether you allocate it by, in the brackets, pass a variable that you assigned earlier, or you use malloc to assign it to a pointer, which is another way to assign it to create an array, that's done at runtime. Question, 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 question. All right, let's give this one more chance. Trying to help people not get zeros. Cesar Hurtado. In other words, whoever didn't get their exam, come get it. Josiah Ka. There he is. There you go. Tristan Tyler. Tristan Tyler. Okay, 2 people who will get a 0. Okay. What time is it? 6:16. Questions? Questions? Question? Question?
If you initialize only Saturday as 1, then would Sunday take the next number after too?
So if I did this? Sunday.
Yes, so the following
would
would just take the numbers after that.
Starts incrementing sequentially from wherever you left off. And in fact, if later on you put something down here with a 2, you'd have 2 things with a 2.
So you
Not
can't.
good.
You have to have a unique variable.
You do not have to.
I mean, like
You have to have a unique name,
name. I mean, yeah.
not a unique value.
Okay.
Usually a good idea to have a unique value, but there are no
So if you run
syntactic
2
requirements.
different enumerators, but then you have the shared name, it would not compile.
In other words, if I put 2 sats here,
No, not like 2 sats there, but
If
like
I
you start
put-
a new numerator, and then you put a sat in a new one.
suppose I did that?
No, like if you do like a new enumerator, like after a new.
Oh, suppose I made
Yeah,
another
a new one.
enu
Yeah, enu.
and called it days of week and put sat in there.
Yes.
I don't think it would compile, but I'm not positive.
Okay.
But those are good, that's a good question too. Hang on. I gotta write my questions. Okay. That was you, right?
Yeah.
Question. Question.
How do you print out the size of an array?
Sorry?
How would you print out the size of an array?
How do you pronounce?
No, print out.
Print out?
Yeah. The size of the array.
I mean, how many bytes are in the array?
Yeah.
Size of? Size of function. In other words, if you have an array, oh, I should think. That would do it. So whatever I allocated, right? If I say int I is equal to size of the name, I would equal what?
Bytes.
Num bytes. Let me think about that for a second, before I tell you something wrong. Because it's going to think that this is an integer array. Size of is going over to question. Question? Question?
For dynamic array is going to be on the test.
Everything is on the test that I covered. That's the short answer to everything. I don't even know why you guys keep asking. Be afraid. What about that? Next.
Or if you were to do a switch statement, with the enu, like to like go on the board, or if for the case statement, if you were to say like case like sat, would you have to put Saturday or like in single quotes, or can you just put it as is?
No, no quotes. Questions? In fact, it wouldn't compile with single quotes. Well, would it compile? Let me think about that. It might compile. No, with single quotes, it would not compile.
Single quote, okay.
With double quotes, it would not compile.
Okay.
And even if it did compile, it certainly wouldn't run forever. Sorry. Question?
Following that, for the case, if you had it equal to 1, would it also?
Guys, knock it off. We'll leave. Go out. Take the conversation in the hallway. You guys step out. I'll call you back in before we start the exam. Go ahead. Go. Go. I'm not kidding. The next step is campus security comes and removes you. Don't think I'll do it? Try me. Why do we do this? We do this for example, right? You have rules, follow the rules. They're not hard to follow. Okay, sorry, what was your question?
So for the case, like same switch statement. For the case, if you also had your case that's just equal to 1, would that also effectively be the same?
So you put some value here?
Yeah, like
So let's suppose we ended up with this. And for value 2, you put a 2 here, yes, it would still work.
Okay.
And if this happened to be sun, it would go to this case.
Okay.
Next.
Oh, what's the size of an int?
Size of an int.
Yeah.
It's computer and operating system dependent. Typically, it's 4 bytes, 32 bits. But That's why you have the size of operator, because if you say size of type name, size of int, it will tell you how many bytes are in that type.
Just a quick question. So if on the exam you were to ask us to do like pointer arithmetics, you would specify the size of the...
You will have all the information you need, is the way I'll answer that question. I do not, it would be stupid for me to ask a question for which you do not have the information to answer it. We believe all. Question? 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 Third row. Third row, third person, question? Question, 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 question.
When you increment a pointer, I have two different notes here. One says that the pointer is moved one type size, and the other one says that it's moved to the next memory location.
It is moved one type size, which is the next memory location based on that type. So that may have been where the confusion came in. And so let me read it. Let's suppose we go with 32-bit and I make this a integer pointer, right? So suppose the value in here is 60, okay? So p name happens to contain a value of 60, right? P name plus 1 will be 64. Assuming the size of an int is 4 bytes. Make sense? Next. Question. Fourth row. Fourth row. Question, 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 question. If I skip you because you weren't paying attention, you'll not have another chance. Question, 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 question. Left side row, question, 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 question. Right side row, question, 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 question. Yeah, allow up to 30 minutes of this, as long as we still have questions. We got 5 minutes. Last round. Question, 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 question.
Would there be a difference between pname plus plus and pname plus 1?
No.
No? Because I was reading, it said the 1 would times the int size and then add it. Or is that wrong? So if I did plus 2, it would be 2 times 4.
So this would be a reference, but if I said pname is equal to pname plus 1.
Okay.
Those are equivalent statements, if that's your question. Right?
Okay.
Question, 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 second row. Question, 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 question. Third row. Question, 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 question. Yes, sir.
What is the size of a pointer?
The size of a pointer variable, for instance, what is the size of pointer pname here?
Yes.
That will also be operating system and computer dependent. It is typically 4 bytes, 32 bits. But it can vary from computer and operating system. Okay. But if you're using them right, you don't actually need to care what the size of the pointer variable is. Because it's going to point to some piece of memory that, and you should never know what the value of the memory address is. You should never need to know. Now, if you start analyzing dumps, that's different. You will then need to know painfully. Well, you know, with the tools these days, maybe not. But it's possible. Question. 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 Fourth row. Question, 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 question. Question, 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 question. Back row. Question, 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 question. Left side row. Question, 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 question. Right side row. Question, 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 question. Sir.
For P News, any chance you could show like an example of this starting up?
Do not show examples. I have to have specific questions today. Last week was when you asked for examples. So if you can make that a specific question.
Yeah, I'm having trouble phrasing it, but.
So try it. What do you want me to show an example of?
P New? Where it would point, how do you know where it points?
P New?
Yeah.
P New is not magic. That sounds like a name of an example, I think. Just like P name here.
The new pointer. The P New plus plus.
Okay, P New had to have been allocated before, right? To some, by malloc, or by pointing it with a reference operator to some already existing piece of memory. And if you say P New plus plus, the compiler knows what type of pointer P New is, be it an int, a character, a float, whatever it is, right? So incrementing the pointer plus plus by 1, that's all plus plus is incrementing by 1, right? It moves it, that type size number of bytes further down. That's all it does. No magic. I mean, the compiler is relatively stupid in that regard. Okay. All right, everything off your desk. Keyboards and mouses lying there. Okay. These two questions. For the empty while, you get a syntax error. For enums with duplicate names, like, okay. These two things, the empty while that someone asked, will produce a syntax error. And enums with duplicate names, for instance, if you had enum days of week with sat, and enum weekend, and it had sat, you will get a syntax error on the declarations. I thought you would, I wasn't positive. The empty while, I thought you would too, but I wasn't positive. Because for the for, you do not. But these are good questions. This is how you learn programming. It's by thinking and asking questions. And in fact, trying it, right? That's all I did. I went and tried it. Pretty sure what would happen, but sure enough. I could have looked it up in a reference book, which is another way to find the answer. But sometimes the reference books are written in such a way that they give you the very technical explanation, but sometimes you still have to go try it just to make sure. I do that a lot, like this online compiler for C. When I prepare lessons and tests, sometimes I think, well, you know what? I've been writing C# all day. Let me go test this. So I drop them into the online C compiler. When I teach data structures, I drop things into the online C++ compiler. When I'm at work, less often because I write C# all the time, I'll drop it into an online C# compiler. Right? It's just a convenient way to answer questions. You know? Knowing everything I know, even I still use it. Because it's very convenient. Okay? And other languages, JavaScript, TypeScript, they have, you know what, I don't know if they have one for TypeScript. I know they do for JavaScript. I'd be surprised if they did not for TypeScript. one of your anecdotes for today. An anecdote is just a short story. They all have meaning, right? That will apply directly if you go into the IT field. But here's your anecdote for today. Today, I had to go back and look at code that I wrote 2 months ago, back in the middle of August. Because someone asked me a question, does it do such and such and such and such? Well, the answer in my head was, it does exactly what you told me you wanted it to do, number one. And number two, if what you said was ambiguous, I would have asked you questions to make it unambiguous, or if what you said was possibly an error, I would ask you questions to resolve that. But I said all this in my head very briefly, to myself, because I didn't remember what the requirement was. That's 2 months ago, right? I don't remember what I had for breakfast today. Nope, I don't remember what I had for breakfast today. So I went back and looked at code. The point is, that code happened to have a do-while loop. Remember when we discussed, someone asked, do you use do-while loops very often? Why don't you just use a while loop, right? And I said, in fact, you don't use do-while loops very often. But it turned out, 2 months ago, I used one. And the reason I used one is for exactly what a do-while loop is designed for. When you know absolutely positively you have to execute it once, and then check the condition, that's when you do a do-while loop. So the case was, we have self-referential database records. So you have a company that points to its parent company, that points to its parent company. You guys have seen movies where they say, well, the companies are all hidden behind shell companies. You see that in movies, maybe? Well, you end up with the same thing for non-nefarious reasons. There's perfectly good reasons for it. Because you separate up your corporate structure so you can manage it, right? There's good reasons for it. Like Irvine, the case we tested in Point was Irvine Company. Irvine Company owns most of South Orange County, okay? And when I say owns, I mean the commercial real estate in it. But they have office buildings, they have apartment buildings, they'll have recreation parks. So they'll break those up into separate companies. So Irvine Company is the parent company, but you'll have Santa Maria Apartments, you'll have Irvine Terrace office buildings, you'll have Irvine Spectrum shops, stores, right? So they'll have different companies that are under the parent company. And then even then, right, you'll have like Irvine office buildings, and then under the office buildings you'll have a company per office building. So that's what I was doing. But you see, I knew there's always one company. At minimum, there's always Irvine Company. Now there may be companies below it, but actually this goes backwards. You start with the main company that you're doing business with, like Santa Maria Apartments. I don't know if there is such a thing, but I know there's a road called Santa Maria over in Irvine. So Santa Maria Apartments, which might feed up to Irvine Apartment Company, which might feed up to Irvine Company. But there's always at least one company, okay? So that was why I used to do while loop, because I guaranteed I have to put this guy in the list, the initial company. And then the condition was, does this guy have a parent? If he has a parent, then I loop back up and get his parent. Then does this guy have a parent? Loop back up. So that was the case where I actually in real life used the do while loop. Just so you know, these things matter and they can be used. Now, could I have figured out a way to do that in a while loop? Probably, but I did the most straightforward thing. It made it clear, and so when I went back and looked at it 2 months later, actually that wasn't even the question. I just happened to come across that code. The question was, if the guy unchecks the box that says, give me the selection of the list of companies, if he unchecks the box, do I put null there so it is wiped out and just the standard company gets put? That's beside the point what the question was. That was the code I came across. So do while loops are real things that are actually used. And I did that before this class started. So I wasn't even thinking about do while loops at the time. That code was written on August 17th. That's the great thing about when you do real work in the real world, they ask you questions you don't know, right? But I just went and I looked up my change sets. Show me all the changes I've made to the entire code base. And this is TFS. What does TFS stand for? Team Foundation Server or something? I don't know. It's source control management, right? Shows me the list of changes I made. Right? Shows me the groups of files I changed. Then I can look within the group of files to show me the file and so forth. That's the real world. How the real world works. Whether it's JavaScript, C#, anything, it's all done in source control. So we can keep track of it for the purpose of going back and looking, right? Now when I see idiot code, I deliberately don't go look and see who wrote it, because it's not going to do anyone any good. It's not going to do me any good. The idiot that wrote it, saying something to him is almost guaranteed not to do any good. Because if it would, he wouldn't have written it in the first place. So, I almost never do that. And in fact, when people say, well, who wrote that? I say, does it really matter? And then, oh yeah, I guess not. Because they don't instinctively get to the answer my experience has told me about, you're not going to fix anything. Now I do have, when I'm the manager, I do have one rule. He who broke it fixes it. It's a self-correcting algorithm, because while he's busy fixing his mistakes, he's not putting in new mistakes. Self-correcting algorithm. Plus, I can keep track of who needs help. Sometimes they need help, sometimes they need the door. And different things in between. All right, that's your anecdote for today. Get those done. Okay. Methods. Let's talk about methods. Let's revisit methods. The thing that I have circled in red, what is that called as regards a method? That I have circled in red, what is that called as regards a method? It says void, it happens to say get salary with the parameter of a float pointer called psalary. But what is that whole thing circled in red referred to as? What is the name of this in general? No, this is the definition of a method, but it has a name that we've talked about multiple times. It has the return type, it has the name of the method, it has the parameter list. It's not a loop.
Declaration?
It is a declaration, but it's a declaration that has a particular name. Like if I say int x, semicolon, that's the declaration, but it's not the declaration for a method. It is called the signature. The signature of the method is the return type, the name of the method, and the parameter list, which can be empty, by the way, but it has a parameter list surrounded by parentheses. If the parameter list is empty, it still has the parentheses. Okay? That is the signature of a method. So when you have a question on a test that talks about the signature of a method, you need to know what that is. Most people define it, most academic things define it as the return type, the method name, and the parameter list. Okay? In reality, it is actually just the name and the parameter list. That's what the actual hard definition is. But for all practical purposes, it's all three. Okay, so why would you write a method? There is a concept. Computer science people, programmers, what have you, they love acronyms. DRY is an acronym. What DRY stands for, and you do not need to know this, this is a mnemonic that may help you. This will not be part of the test, you do not need to know this. What it stands for is don't repeat yourself. Don't repeat yourself means don't write the same piece of code twice. Write it once, put it in a method, and then call the method multiple times. That's what don't repeat yourself means. So, in one of your programs, maybe program 3, I'm guessing. It says use methods to do the same thing you were doing in program 2 and program 1, right? And one of the things you have to do is get a guy's salary. You may have to get other things, I don't remember, but this is just an example, okay? So rather than get a salary 5 times, like in program 1, you said enter salary for employee 1, scan F, well, enter salary for employee 2, scan F. You did that 5 times. You repeated yourself 5 times. When instead, what you can do is write a method, a single method that gets the salary, prints out, give it the salary, and you do 1 scanf, and then you call this method 5 times. That's what don't repeat yourself means. Don't repeat yourself means rather than write code multiple times, write it once in a method and call the method multiple times. Now, remember, we're doing very simple things here, so your method is going to be fairly simple. But when you're out there making, 6-figure salaries, your methods are not going to be simple. You're going to be complex and do a lot of things. So that's why you write the methods, because it's a lot of code that you're going to don't repeat yourself with. That's not the only reason to write methods. Other reasons to write methods are to make your code clean. So in other words, let's suppose you have int main here, and you say for int I is equal to 0, I less than 5, I plus. And you call get salary with whatever parameters you're going to pass. We'll worry about the parameters in a minute. You call get overtime rate with whatever parameters you're going to pass. You call get hours worked with whatever things you're going to pass. And then you call calculate pay. So when you come to this program, rather than see all the complexity of get salary, get overtime rate, get hours worked, and calculate pay, you see 4 relatively simple method calls. And then you have a method called get salary that has all the complexity of get salary in it. Yes, sir?
I assume you have to define what the method is before you write it, like above, before you call it the method.
We'll get to that in just a minute, but yes, the answer is yes. That's on my list to cover tonight, is making sure, yes, we'll get to it. And there's different ways to do that. So the point I was getting at is, you've got, so a person can look at this right here and immediately understand what's going on. You're going to get the salary, you're going to get the overtime rate, you're going to get the hours worked, and you're going to do some calculations, right? So from that level, he sees what's going on. And then he says, okay, I need to know how he gets the salary. So then he goes and finds the method called get salary, and he sees what code that has in it. And that may call multiple methods. In fact, it will. We know what method is this guaranteed to call. So first person, second row. What method is get salary guaranteed to call? It's a library method. What are we using to get any input? Scanf. So just because it's a method in a library that you don't have to write, you're still calling a method. So this is why we use methods. For 2 reasons. One, don't repeat yourself because you're going to do it multiple times. And here's a perfect example. You're going to do it in a for loop. For loop's a good way to do things multiple times. If you're doing the same thing, you just vary the parameters. This is one of your challenges in writing program 3 that you'll get to. Because in program 2, you had to start using arrays and for loops. So you have to figure out how to pass the right parameters to get salary. We'll talk about one example of that in a moment. But the first important thing is to understand why you're writing methods. We don't tell you to write methods just because some computer scientist thought it was cool. We do it because it makes everything better. so that when I went back and looked at my code from 2 months ago, I had written clear methods to do specific things. One of the methods that I wrote was get company hierarchy. And all it did was give me a list of the company hierarchy. That's all it did. Didn't do anything about displaying, didn't do anything about figuring out who was the, well actually it did. It was done in order of hierarchy, but that's all it did. And I had other methods that had to translate keys into names. Had to make database calls and this and that and the other. But they were all clean separate methods. So that the method name, remember we said use descriptive names? And I use names that are 20, 30 characters long. Well, probably not 30 characters, but fairly long names that describe exactly what the method's going to do. And if you can't come up with a relatively concise name that says what your method is going to do, your method is probably too big. And it should be multiple methods because it's doing too much. This is just programming advice. Hopefully that makes sense as to the why we do something. Sir.
So you write them separately, and then you write the signature and the for
No, you write a call. The signature is simply that first line that doesn't contain the body. So, as someone else pointed out, that's the declaration of the method. We'll talk about the declaration of header files and stuff in a minute. Back to his point about something has to be declared before you use it. But this is calling the method. This is a method call, or a function call. Method and function are interchangeable words. The word function is because it provides some functionality. Method is because it's the method of doing something. That's where those two names came from. But, okay, let's talk about his point first. In C, everything has to be declared in some way, shape, or form before it is used. In other words, the compiler has to know about it before the compiler can let you use it. Integer x. If you haven't defined integer x, I think on the previous exam, age was not declared. That would give you a syntax error. Right? I know you guys probably don't remember this, but we did talk about this. It might have been the first class, but it was certainly by the second class. You have to declare something before you use it. It gets you have more options with methods that we're going to talk about. But in C, in general, before you use it, you have to declare it. No matter what the it is, be it a variable, or a structure, or an enum, which is a variable type, or a method. Now, the question.
So would it be better to initialize all variables outside of any of your methods?
No. But not for the reasons you think. There's a reason called, the reason is, everything should have the minimum scope. We might talk about that later. We might not. Doesn't ever get to it. And there's reasons for that too. It prevents mistakes. Same reason you use braces, right? It prevents mistakes. You don't have to do it, but it prevents mistakes. Same reason for the minimum scope. It means as close to the use as it's going to be is where you should declare it. Okay, let's get back to methods. Okay? Now there are two things you can do with the method. There is declaration and there is definition. Let's talk about what that means. Well, let's take this example right here. This is a method called getSalary that takes a float pointer named pSalary. And then I wrote the body of the method right here between the braces. Okay, so I'm going to write this and then explain the pieces of it. This is a declaration because that's all. It's declaring the signature of this method called getSalary. It is a declaration. This thing right here that has the identical signature, we'll come back to that identical part because I'm sure some of you have questions. This is the definition because it has the body of the method between the braces. This is a declaration. This is the definition. Now remember how I said everything has to be declared before you use it so the compiler can see it? Here, I've declared it. And I could put the body somewhere else down below. Let's suppose I didn't have int main here. Let's just suppose linearly in the file, I put main there. Okay, main is what? What is main? Why do we have to have a main in every program? It is a function name. Why do we have to have a function named main in every program? Has anyone tried to write a program without main in it and see what happens? What happens?
It doesn't run.
It doesn't run. That's right. It's the definition of where the program starts. It is the function where the program starts every time. In C, C++, and C#. It's a little more complicated in C# and Java, but everything starts at a function named main. Okay, so in this particular main, now keep in mind the order in which I put them in the file. This main is going to call get, it declares a float F, and it calls get salary passing a pointer to F. That's what the reference operator does. Oh, you should have heard it when I pushed the down button on all the computers. There's all sorts of clanking and stuff going on. So that might be the remnants of declanking. Anyway, this thing calls get salary, but get salary does not have definition yet as far as the compiler knows. But what the compiler knows, the compiler says get salary is declared, and I know everything I need to know about it. I know what its return type is. I know what its parameter list is. The parameter list is the type of the parameters and the number of parameters. And that's all the compiler needs to know to generate code to call the method. You can define the method. This is the definition that comes from the word define. You can put the definition of the method after it as long as the declaration is here. This falls under implicit homework. You have to go home and study this. Listen to the words, make notes, hopefully you're scribbling notes down, typing them in something, whatever, and you're going to go study. And then hopefully you'll even take it a step further and write some little practice programs that are trivial, but they show you exactly what I've done, right? This is what I've written here is trivial, right? Everybody can agree this is trivial, I hope. But do some practice and you'll see how it works. And then put // right? Do this, make sure it works. Okay. Then put // in front of that declaration, which effectively comments it out, and you'll see you start to get compiler errors. See what those compiler errors are. That'll be a useful thing to know. Because that compiler error will begin to help you make sense of why it has to be declared before you try to use it. But this is a convenient way to say, I'm declaring it without defining it, and I'll define it later. Now you say to yourself, why might I possibly do that? Why don't I just define it up here? Because if you're writing a lot of code, this one file gets very, very, very large and cumbersome to work with. Let's take an example that you guys already use in this regard. Right now your programs say #include stdio. It actually says stdio.h. Now the difference between the less than and greater than versus the quotes is it says look in standard locations of the compiler for this one, stdio.h. That's the only difference between the less than and greater than signs versus the quotes. for almost all purposes, certainly for all purposes in this class, it won't matter. Okay. So you do that, and you do that to allow you to use what function? Next person. What is stdio, which stands for standard IO? What function does it allow you to use?
Scanf and printf.
Scanf and printf. And there's a whole bunch of others, but those are the ones that we care about. So go into one of your programs and do that, and put scanf, and see if you get a compiler error. I bet you some of you have already experienced that joy because you accidentally removed the pound include. Okay? This is why. So, stdio.h contains only the declaration for scanf. It does not contain the definition of scanf. It only contains the declaration. And why does it contain the declaration? So that you've told the compiler, I'm going to use something in here. One of those things that you're going to use is scanf, so it knows what scanf is. It knows what its return type is, and it knows what its parameter list is, and it knows what its name is. So this is why you have the ability to declare a method and later define the method. Sir?
You said the stdio.h contains the declaration of scanf, but it doesn't contain the what?
Definition.
Of scanf?
Of scanf, the actual code of scanf.
Only scanf, not printf, right?
Sorry?
Only scanf, not printf.
No, it contains a bunch of things. Scanf, printf, and others. The ones we've used are scanf and printf. It contains more. But it only contains the stdio.h, only contains the declaration. So that you've told the compiler, I'm going to use this thing, right? And the compiler doesn't need to know what the body of scanf is. He only needs to know the signature. That's why it's important to know what the word signature means, right? And we've talked about it at least 2 or 3 times before this. Return type, the name of the method, and the parameter list. Even if the parameter list is empty, you still have a parameter list. And that parameter list has to be satisfied. In other words, you have to have those parameters passed for things to work right. So then, you're asking yourself, okay, great. We've given it the declarations. How does it actually run the code for scanf? That should be your next question. If we only gave it declarations with no code, how does scanf do anything? Right? That should be your next question. So, and it's a good question. Now I have to tell you how computers work again, or in this case, how compilers work. So this is a little simplified, right? But this is how your program actually gets compiled into something that will run. You have a compiler. The compiler reads your input. And what that compiler is doing is 2 things. It is doing syntax checking to make sure you declared something before you use it, to make sure you put parentheses around the argument of your if, all those things, all the syntactic things, okay? It's doing that, and it's emitting code. Now, one of the pieces of code it has to emit is a method call code, right? Now, whatever the assembler language that is emitting code for, be it x86, x64, for the iOS, I forgot what Mac's chip used to be called. Mac gave up, they went to Intel. And then Microsoft immediately walked away from Intel. They'll do all sorts of things. It doesn't matter. The chip runs an instruction set, right? And those are machine code. So you actually go from higher level languages like C to assembler code, which is still not And then the assembler code goes to machine instructions, which are just numbers. Zeros and ones when you get right down to it. There's multiple levels of it. Well, what the compiler does is he compiles what you give it, right? Including this thing called pound include stdio8.h. And he just builds up a list. Okay, it's called a symbol table. You don't need to know about the symbol table. You don't need to even know about compilers and linkers. But to explain this properly, I have to tell you about them, okay? So that you'll understand how it works. So there is no magic, right? Remember, there's no magic. You don't really, smoke doesn't really run electronics. There's no magic. Everything works a certain way for a reason. So the compiler goes through your code, makes sure the code is written properly, so you don't get any syntax errors. So let's assume that you have no syntax errors. Then the next step the compiler causes to run is a separate program called the linker. They're not always separate programs, depending on how the compiler is written. But it's called the linker. What does the linker do? The linker does exactly what its name implies. It links things. So you have a declaration called scanf that you told it about. I want to use something called scanf. It has a whole list of what you might use, but you actually use scanf. So somewhere in the compiler's table, it wrote scanf with whatever parameters you're going to use. Then the compiler says, okay, fine. How do I get to that? How do I get to the actual code? Now the actual code, again, this is the simplified version, is going to reside in a compiled file called stdio.dll. DLL stands for Dynamic Link Library. The reason it's called Dynamic Link Library is because the linker is going to resolve the addresses for scanf into where they actually are in this piece of code. You don't need to worry about how it does that. But suffice it to say, in the assembler code that it generates, it ends up taking your call on scanf and pointing it to somewhere in this file where the actual code for scanf resides. And that's how it works. So the only thing you have to do is tell the compiler, I want to use something called scanf. And the compiler doesn't even know what the guts of scanf are. It doesn't know what the code is. Because all it knows is that the code lives in stdio.dll and it has a name. So he reads this file, and at the beginning of this file, it has a list of names. One of those names being scanf. And it says that code resides in this file at location XYZ, whatever it is. So that he knows, he the compiler, he the linker, says whenever scanf is called, start executing code at XYZ. All the compiler needs to know. He doesn't care otherwise. Because whoever wrote this, that's his problem. He just starts executing the code that you said to execute.
I'm sorry, I'm just getting a bit confused. What does this have to do, like, how does stdio.dll, how does it relate to methods?
That's where the method actually exists. Remember, what's this stdio.h? What's an stdio.h?
Library.
Nope. What is an stdio.h? It contains just the declarations, like this. It doesn't contain the definition, it only contains the declaration. You have to study. You wouldn't expect to know that right now, right? But next week, you should know it inside and out. Because you'll do your implicit homework. So stdio.h just contains the names. The declarations, one of the most important part of the declaration is the name, right? Later on, the compiler and the linker will put all these things together to make scanf do what you want it to do. But the point is, in your program, you only gave it a list of declarations. Now, if you back up one further step, if you remember why we have declarations, it's because you want things broken up into multiple files. Because otherwise you'll have one big monolithic file that no one can work on. Or perhaps you have 3 people working on different things in the same file that leads to collisions as you're trying to work together. So if you break things up into separate files, it makes life easier for everybody, right? But not only that, it makes it clean, modular, and maintainable. Not only that, this is how the entire system is set up. This is how all the systems are set up. Java, C#, C++, C, Python, PowerShell, everything. They're set up into little libraries. If you look back at your notes from the first or second night, probably the first night, I wrote down language or compiler, and I wrote down libraries, and I wrote down IDE, which stands for Integrated Development Environment. More Implicit Homework. Go read what those things did. You should have gone home and read it that week. What's the difference in those things? The libraries are essential for the language to be able to do anything. Because the language is relatively simple and straightforward syntax. It is the libraries, the canned libraries, that give it the power. Standard IO, stdio.h, stdlib.h. You have a lot of string functions in there for dealing with strings that we're going to get to. That's where the power of systems comes from. Not from the code you write. It comes from the code that other people have written that you're going to use, right? Scanf being a perfect example of that. Somebody else wrote that years ago, and they defined it well, and it does this. You don't have to write all the code under scanf. You just use scanf. All modern computing systems are like that. They weren't written overnight. They were built up over years. Apartments.com, 7 or 8 years ago, was not nearly the site that it is today. Because over the last 7 or 8 years, people like me have been adding small bits of functionality to it. To do different things, to do additional things. And that's true of everything. It's true of Google, it's true of Chrome, it's true of Facebook, it's true of Twitter, it's true of all the programs you use. Here's a famous quote for you. I forgot who said the quote. But someone was saying to this scientist, "You're a genius, you're wonderful. Look at what you've done." And the person replied, "Only because I stand on the shoulders of giants." The people who came before him.
I think that's Isaac Newton.
Might have been Isaac Newton. Wouldn't surprise me if it was. Because all these people figured out this, figured out this, figured out this, and everybody adds a little bit to what they figured out. The same way with computer programming, right? Everybody adds a little bit to what you're doing. So, however many years ago, somebody wrote scanf, not because he thought, oh, the world's going to use this. He had a problem to solve. Just like I was running one of the first 10 email programs, I didn't think about that. I was solving a problem, and I couldn't tell that person over there something without picking up the phone that he might not answer. So I wrote email. I called it mail. Just called it mail. I didn't call it anything else like email or email or anything like that, right? Because I wanted, it was in my head, right? It was a computer answering machine, right? Where I sent it to him, he would get to it when he got to it. That's how I thought of it. And now, what's the logical extension of email that all you guys use? Messaging, text, whatever, right? That's the logical extension of email, except it's a little more immediate in many cases. Because we all walk around glued to our phones. I love these people walking in crosswalks glued to their phone. Like, you know, my generation thinks they have a death wish. Your generation thinks nothing of it because, in fact, everybody's looking for the idiot walking with his phone. But it's okay, it progresses, right? My generation is different from your generation, right? In many ways, you guys are a lot more technologically savvy than I am. I pretend to my daughters that I'm less technically savvy than I am. I don't think I sell it real well, but I get them to provide tech support for their mother, and I don't have to be involved. It's great. Mother and grandmother. Mother, grandmother, and children. I used to be in the tech support business without being paid. Everybody said, oh, how can you? Yeah, it's like a 60-hour-a-week job in addition to my regular job. That's why I foisted that off to my smart children. They're smart. They probably know I did it on purpose. But they're very helpful and kind children. As you can imagine, that might be their mother's influence. Okay. But this is how computer systems hang together. Things are built by other people, and you simply include a reference to them. And then the compiler and linker figure out the rest of how to make scanf work. As long as you have done these things correctly, put in the reference to it, i.e. the header file with all the declarations, and your syntax is right. Because you can write syntax that will compile, but be wrong. Because, let's take an example of that. Let's go back to this program now. Okay, so first of all, you understand you're going to go study the difference between a declaration and a definition. You're going to study that carefully, I hope. I'm not saying it will be on the exam, but I'm just saying. Okay, so, now this applies directly to program 3. I don't remember what the details of program 3 are. The details of program 3 may say, write a method that gets multiple things. I don't know what I don't remember what it says right off. But I'm just going to show you how to write a method to get one thing. And that's the salary. And instead of the salary, let's call it the rate. I'll just change these variable names to rate. I mean the method name to get rate. This method name to get rate. This float is just a variable called rate. And this parameter to reference to rate, which creates a pointer. Because I think rate is more close to what you actually have to get. How many dollars per hour does the guy make? 2. He's vastly underpaid. It makes calculations simple in your head. Okay, so I made a declaration. Now, one of the things you'll notice about this declaration is that I gave it the name P placeholder up here, but I gave it the name P rate down here. Why does that not matter? I gave you the hint here, it's a placeholder. What matters is the type. It is the float pointer in both cases. It has to be identical in type. The name is just a placeholder, right? In the declaration, you don't do anything with P placeholder, so it doesn't matter what name you give it. It only matters what the type is.
So you can write literally anything in P placeholder, any non-reserved.
Yeah, I can write XYZ. It doesn't matter. What matters is the type, which is the float pointer. And that has to match the type in the definition, which is also a float pointer. And I just happen to give it a different name.
Why would even a person write 2 different variables for the pointer? It just makes it more confusing.
To you, but it makes it simpler in the real world. Right? Because this person who writes this declaration, this person who went over here and however many years ago, 30, 40 years ago, wrote scanf, he picked names for his declaration. He had no idea what name you were going to use, nor did he care. Right? He had no idea what the Apple developer who provides the definition of scanf is going to call it, or the Microsoft developer who writes the definition of scanf is going to call it, or any of the other developers. Lots of people have written scanf or their particular computer system and operating system. And I guarantee some of those names do not match the name that was originally used. That's the point. It doesn't matter.
However, I'm only talking about after the pointer, not before.
You mean P rate?
Yes.
It doesn't matter what the name is. This is a declaration, it's a placeholder. Right? It's
My
like,
question is that why would a person write two different names? if it's
because
the
it might be
same-
two different people.
Huh?
It might be two different people.
Ah. Yeah, that's,
Some people will write all the definitions, right? And then some people will go implement it. And the only thing they care about is that it's the float pointer. The name is irrelevant. It's a float pointer. He's going to write the name convenient for him to use in his code. So, in our case, we're having a method called getRate. Return type of void, which means it returns nothing. And it takes a float pointer, P-rate. Now, since you've all done your implicit homework regarding pointers, the reference operator, and so forth, you understand that when this main method declares float rate, and he can pass a pointer to rate simply by putting the reference operator in front of the variable name rate.
Does the scope have to be the same for the method declaration on top and the body written below?
The scope, which we've only touched on a little bit, it has to be within the scope. You can have multiple scopes. Think of them as concentric circles, right? Where the larger the circle, the higher the scope. So, yes, you can have this here. But in fact, you cannot declare methods inside of methods. Now, other languages like Algol and some Pascal and some others allow you to do that. And in fact, C# started allowing you to do that. But C and C++, it's not true of C++ completely anymore. For the most part, C and C++ are single level languages. They have single levels of declarations for methods. The only thing for which they do not have single levels of declaration is variables. You can declare variables inside of braces, inside of braces, inside of braces, and the scope is limited to the closest containing set of braces. We'll talk about scope in more detail later. But for these purposes, there's no other way you could have done this, because you couldn't have declared it inside that main. Probably give you an error. Because it's monolithic and all methods have to be at the same level. Now in C++ and C#, they're object-oriented, which means you have objects which are like containers. It gets more complex there. But for the purposes of C, it's mostly monolithic like that. When we get to structures, you're going to see that it's not, that you can do more. We're not there yet. For our purposes, it's monolithic. All methods are at the same level. Okay, so the declaration and the definition of getRate have to have the same signature, and we're passing a float pointer. Why do you think we're passing a float pointer instead of a float? Go back in your notes. We talked about pass by reference and pass by value. Passing a pointer is passing by reference. Because you're not passing the actual variable, you are passing a reference to the variable. Which is why the ampersand is called a reference operator. It gets you a reference to the variable to its right.
So is the asterisk the dereference operator?
The asterisk is the dereference operator. We'll talk about that in a second. So we want to add to this program just for the sake of demonstration. But first, let's get to the scanf. We know that scanf has to take a pointer variable, a reference, right? So the parameter p-rate to this method is already a reference. So I'm passing it a reference. Inside scanf, it's going to say, suppose it called this variable p rate. It didn't, but suppose it did. It's going to say star p rate to assign the value to it. But let me show you the same thing we would do. Suppose after we got that rate from the user input, we then want to print it in this method, which I don't think is part of that program, but see, I start sliding off to the right as I write things. Okay, I want to do a printf. I've given it the format specifier %f, because it's a float. What do I put here to print the value that scanf received?
The reference operator with the p rate.
Okay, it's going to contain some part of p rate, that's for sure. What else, if anything?
I would think you have to add the ampersand, right?
The ampersand is the reference operator. What's the dereference operator?
The asterisk.
What every one of you should do this week is write this down, put it into a program, make sure it does what I just said it would do, and then understand every single facet of it. If you have not done that, you have not done your homework. Sir?
So for scanf and printf, the scanf doesn't have an asterisk and the printf does?
Correct. In this example. But it's important to understand why. Being able to write this by rote will not help you on the next exam. You have to know why these things work the way they work.
So p rate is referring to the memory location, and then when you use the dereference, it gives you the value that it's pointing.
Exactly correct. P rate contains a memory location. Dereference says get the value at that memory location. Exactly correct. P rate is a pointer. As you see, it's a float pointer that you passed in as a parameter. That's what P rate is. It is a pointer. A pointer is a reference to the variable. In other words, the pointer contains the memory address of the variable. When you dereference it, you get the value that is at that memory address.
I'm not sure if this passed over my head, however, the word rate is a trivial question. I see two rates, one with a capital R and with a small r. Just to be honest.
There's no rate with a capital R.
Sorry?
There's no rate with a capital R. That's not rate. That's P rate.
What about the ampersand rate?
Ampersand rate
Yeah.
is this rate is the same as that rate. Ampersand says, what is the ampersand operator?
Reference.
The reference operator. So reference rate, in other words, pass a reference to the rate, which ends up being a pointer, which is why you can pass that as the pointer parameter to this.
Sorry, I should have known that.
Remember how I've been preaching you have to understand how pointers and references work? As you hopefully have come to understand, I don't kid you about anything. What I say is actual, literal truth. You have to understand that.
I should have known that. I just got confused. Two same words for some odd reason.
It's
My fault.
it's a repetition. You know, that's what learning is, right? It's repetition sometimes. Repetition, repetition, repetition until it sinks in. Sometimes it's immediately obvious. I wish I could know which is which. Because it's different for each person. There's probably a way to teach me how to draw a picture. So far, no one has been successful over a lot of years. But there's probably some instructor who could figure out how to do it. I just haven't met them. Plus, I haven't tried real hard, to be honest. But you guys are taking the class. You kind of have to try hard. So that is your implicit homework. Take all that down and understand what every piece of it does, why it does it, and how it does it.
So since you already declared the ampersand sign for rate that says that's a pointer, you don't need to write the ampersand sign to scan out again.
That's essentially correct. In other words, this method takes a float pointer. What I need to give scanf, because this is %f, is a float pointer. I have a float pointer, it's named prate. I just give it prate.
How come dereferencing a pointer gives you a value? Like, what does dereferencing precisely mean?
Dereference says, go to this reference, prate,
Okay.
get the value at that memory location. A reference is a memory location.
So it's like the pointer.
This is a pointer.
Oh, okay.
It says get the reference, get the value at that reference. Get the value at that pointer.
Oh, okay.
Saying the same thing. Get the value at that memory address. Saying that's 3 ways to say the same thing. Get the value at that reference, get the value at that pointer, get the value at that memory address. Those are identical statements. You want to know the bad news? Perhaps from your perspective? When you go to write actual code in C# and Java and stuff, you won't have a pointer. The good news is you will understand why you don't have to have them anymore and what those languages have abstracted for you. And that's why you have to take this class, so that you understand what's really going on. Almost nobody's going to go out there and write C. Right? I get job offers in C because C happens to be laying around on my resume on the internet. Right? Once it's on the internet, it's on there forever. Right? So I got a Fortran offer. Can you come help us write some Fortran? Or actually, the offer was, can you help us translate Fortran to C? And my first thought was, why would you go to C? Fortran to something, but not C. C#, Java, you know, anything but C. You know, that was my thought yesterday when that came across my desk. But there's Fortran on my resume. Perhaps I should clean up my resume. I've been writing other stuff for years, and San Diego Federal Credit Union called me up. They said, we have this C program that's got to get by federal regulators. We need an expert to review it. So me and my buddies were going to Vegas that weekend anyway. So I said, sure, Allen Drive. 4 hours there, 4 hours back, $1,000+ I don't remember how much I made. Wasn't doing anything else. Hadn't touched COBOL in years, but you know, it's COBOL. Right? In some ways, COBOL is worse than C, believe it or not. That's a true story. Back in the late 90s, San Diego Federal Credit Union. Well, I don't know if it's Federal Credit Union, but the big credit union of San Diego. Now I'm going to have to go back and look up how much I made on that. I hate to ask if there's any questions, because there's probably a lot, but write this down and go start executing it and walking through it, figuring out how and why it works. One of the ways to do that is by changing things. You know, instead of putting prate, put an ampersand in front of prate, and it'll quit working. Try to figure out why. Put a star in front of prate. It'll quit working. Try to figure out why. Another name for this declaration. This is just, you have to know this, right? Another name for this declaration contains the signature of the method. Signature is the return type, the name, and the parameter list. Another name for it, when you only give it the semicolon, another name for the declaration is the prototype. That's just the official C name. Well, the official programming names. It's used in lots of places. It is the prototype. The declaration is also known as the prototype. Remember, prototypes are just demonstration things. They don't actually work. Elon Musk put his prototype walking robot out this week or last week, right? It can barely walk and not do much else. It's a prototype. That's where the word prototype comes from. It just tells you the bare minimum. It's better than the last one where you had a person dress up in a suit and dance around the stage. Who uses Twitter? Okay, I don't, but Elon Musk decided to buy it again. That was news yesterday or today, I forgot. The void return type we've talked about. Void return type simply means it's not going to return anything. You can still use the return keyword inside the method to exit the method. You just say return semicolon, say exit the method from wherever that return statement is. Remember we talked about return, break, and continue. Break, continue for use in loops. Break saying exit the loop. Continue says don't do the rest of this iteration, start the next iteration. And return is exit the method. That's what return means. Look that up in your implicit homework. You probably already all used it. In fact, I'm certain you have, because when they give you your little prototype method, that int main, that you then are going to fill out your code, they almost always have return 0 at the bottom of it. So you've already been using it actually. And we talked about header files. Whose brain hurts? My brain hurts. My brain hurts because I have to try and think of 3 or 4 different ways to convey the same thing. So, did I answer your question about things have to be declared before they're used? Probably in far more detail than you wanted to know. But that's how it all hangs together. Questions?
Why do we float key placeholder? Is it still Kyle's value?
I'm sorry, why is this a float?
Why do we need that?
Oh, okay. So it has to be a float because his pay rate may be $2.50, 2.5, rather than an integer. The reason it has to be a pointer is because you're going to pass it to scanf, and in fact, the actual location of where you're going to put that value is outside of this method. This method getRate, we call from inside of main, and we pass it a reference to this variable float rate up here. This is where that value actually lives. It doesn't exist in this method. The only thing this method has is a reference to that variable. Reference operator, that variable, and I pass it to this method. This method sees it as the name prate. And then this method can do things to prate, namely, call scanf and say, get a value and put it there. Put it where this points. That's why it's called a pointer, because it points to something.
I'm a little bit confused because if you leave out the float key placeholder, it still runs the same.
When you say leave out the float placeholder, you mean put paren here?
Yeah.
I doubt it.
It works, but you can't do the same things.
That's the other thing you have to be careful about in C. All sorts of things will compile and run. That doesn't mean they're doing the right thing.
If you get rid of the whole first line and just have the, because technically, oh wait, it's not declared anymore.
Because I did that, which is effectively not declaring it, right? Commenting it out. What would happen here? What do you think would happen?
Then void getRate, the actual like where you define it doesn't exist because it was, or well, I guess it does exist, but it would never. Actually, no, it wouldn't. It wouldn't go to anything.
It does exist. At this point, does the compiler know about it? So therefore, what would happen? No, it wouldn't blow up running. There's two parts of running. There's compiling, and then there's running. They are different things. So, because the compiler doesn't know about getRate at this point, what would fail? The compile or the run?
Well, they compile, but
yes. Let's just stop at that point. We'll come to the next one in a second. The compile would fail. So if the compile fails, it'll never run. Okay. So what was the second point you were going to say?
I was going to say I wasn't understanding where compiling happens. Then I guess
it has to compile before it can run. Now, unfortunately, in that online compiler I showed you, they have the button that everybody uses is run, right? it should actually say, well, it should actually say compile and run, because that's what it's doing most of the time. Actually, that's what it's doing every time. It should say compile and run. But they're doing something for your convenience. And it is convenient, but it's not completely expressing what's going on. That's why I'm here. Questions? Okay, my brain hurts. I'll be doing hard things at work too. That's it for tonight. Please, please, please. Study, try, put it in there, see what happens. I'll be here for like the next 20, 30 minutes, as long as anybody has any questions.